Good morning, sir.
Now, let us solve some of the problem related to equivalent capacitance. Let us see here. If you are given certain number of capacitor, you have to determine this A, C. This is point A, this is B. If each capacitor have capacitance C, if each capacitor have capacitance C, wait, let us see. So here, this is 3C, this is 3C, this is 3C, this is C, okay? This is 3C, 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 C, 3C, C. Find the equivalent capacitance across point A and B. Find the equivalent capacitance across point A and B. Yes, beta. Tell me. What is the question here? Find equivalent capacitance across point A and B. Across point A and B. Across point A and B. Let us see here how we have to.
Sir.
Let us see here. It has been. Wait. Yes. See here, beta. You are given this network of capacitor. How many capacitor? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 capacitor are connected like this. And you are asked to determine the equivalent capacitance. You are determine the equivalent capacitance across point A and B. So, beta, how you will find out this one? If this circuit, you don't touch here because nothing is visible to you. You start from one side. But a 3C, 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 how they are connected in series? 3C, 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 they are connected in series. So you start from here. You must solve this three. But for series combination, 1 by C equivalent is equals to 1 by, or let the equivalent capacitance of this 3C dash, 1 by C1, 3C, 1 by C2, 3C, 1 by 3C. But LCM is 3C, 1 plus 1 plus 1, 3. 1 by C, so 1 by C dash, just reward this, C dash is equal to C. So, after solving this one, you will write here, you will again draw the circuit like this. In the next step, you can draw this circuit like this, with A, like this. You can draw like this. This. This circuit here, further draw this 3C, C, 3C. Now here, what is the equivalent capacitance of all these three? Equivalent capacitance of all these three is, draw this circuit, and now equivalent of these three, which are connected in series is C. So you write here C. This is the equivalent capacitance of all these three. See. Now you see here. This is C, this is C. How they are connected, beta, tell me. How they are connected? C and C, these two are in parallel. So for parallel combination, C dash is equal to C plus C. Parallel combination, it will be 2C. It will be 2C. It will be 2C. Now in next step, you will solve like this. The equivalent of these two are 2C like this. Now you see here, what will be our next step? The equivalent capacitance of this three. How they are connected, beta? How they are connected? Tell me. These are connected in series. So for series, no. These three, I am talking about these three. This, and this. These three are in the same line. On the same line. So they are connected in series. So let the equivalent capacitance is C double dash is equal to 1 by first one is 3C. Second one is 2C. For third one, it is 3C. What is the LCM? 6C. This is 3 2s are 2 plus 3 plus 2. Like this. 1 by C double dash. So 3 2 5 2 7. So C double dash is revert this equation. C double dash is equal to 6C upon 7. Now you rub this one and next step you write 6C upon 7. The equivalent capacitance of these three are C double dash, which is equals to 6C upon 7. Now you see here in the next step what we will do. In next step what we will do. What you are observing, beta? How these two are connected. Beta, again tell me, Kamal, tell me how they are connected, beta. Anis, beta, kaise connected? How they are connected, beta?
Series.
No, beta. Their one point are connected as same point, other point are connected as same point. That is two are connected in parallel. But how they are connected? Parallel. So let their equivalent resistance is C triple dash. So in parallel combination C plus 6C upon 7. We generally add up C1 plus C2 formula we apply. Now 7 plus 6, 13C. 13C upon 7. You rub this one. In next step, you rub this one and write down. This is C dash dash dash. Write down 13C upon 7. Now see in next step how you will solve. How they are connected better. Now these three are connected on same line. So these three are connected in series. So these three are connected in series. Now let this the equivalent of these three capacitances dash dash dash. 1 upon for series combination. What is the formula? Dash 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 is equals to triple dash. Now 1 by C1 3C, 1 by C2 triple dash. This is 4 dash. Now this is 13C upon 7. This one is 3C. Now what is the LCM? 39C. 13 plus 21 plus 13. So 1 upon 3 what dash 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 dash. Revert this. C what dash 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 is equal to 39C upon 314 437 47. 39C upon 47. Now again beta we have derived the equivalent of these three capacitor connected in series at this one. Now you rub this one. And in place of this one, the equivalent capacitance is of these three is 39C upon 47. Now here, how many capacitors are remaining? Only 2. So final capacitance is called C equivalent is in parallel combination we generally add up this 39C upon 47. 47C plus 39C, but I see you just calculate it. कुछ बचा ही नहीं. 86C upon 47. This is your equivalent capacitance. In this way, we can determine the equivalent capacitance of such type of circuit. Yes, beta. Are you getting or not? Yes, everybody. Beta. Now let us see. We will solve some of the problem. See here, beta, see here. Last year, in JEE mains exam, one question was there. There are n number of plates, parallel plates. There are n number of parallel plates are there. How many parallel plates? N number of plates are there, parallel. And they are connected alternately to each other. This is connected to this, this is connected to this. This is connected to this. How they are connected? This is connected to this. This will be connected to this will be connected to this. It means they are connected like this. How many number of plates? N. Let's assume there 1, 2, 3, 4, 5, 6. But see here, or 6, 7, we are, let we observe only the total 8 plates. What was the question here? There are n number of plates parallel to each other and alternating plates are connected to each other. How many total capacitors will be formed? Yes, beta, anybody? Anybody can give answer? How many total capacitors will be formed? Alternating, बेटा ये इससे कनेक्टेड, ये इससे कनेक्टेड. See, this is connected to this. This is connected to this. This is connected to this. This is connected to. No, nothing. This is F1. Second one is connected to fourth. Fourth one is 6, 6 to 8. Now let this be negative terminal and let this one be the positive terminal. So this will be plus. This is minus, minus. This is plus, so minus charge will be induced. Here minus. So here plus. Positive place, this will be plus. And this side will be also plus. Plus, minus. See here, this is negative plate, so this will be also minus. This is positive plate, this will be positive plate. Beta, see here. This सारा plate क्या होगा beta? This will be positively charged. This will be negatively charged. This will be negatively charged. This will be positive, positive, positive. Beta, tell me, all the positive plates are connected at the same point. All the positive plates, they are connected at same point, and all the negative plates are connected at same other point. What you will call this combination? Yes, beta. Yes, anybody? Beta Kamal, can you tell me what is the type of combination? Parallel or series? Yes, beta. Anybody? All the positive.
Parallel.
Very good.
Sir, series.
No, this is parallel combination. All the positive plates are connected at same point, and all the negative plates are connected at same another point. What is the total number of plates are there? 8. How many capacitors form? 1, 2, plus minus 1 capacitor, minus plus second capacitor, plus minus third capacitor, fourth plus minus, fifth, plus minus plus, 6, plus minus 7. Now, out of 8 capacitors, when they will be placed parallel to each other, 8 capacitors form. Now, if n number of capacitors will be there, then total capacitor form will be n minus 1. If alternating plates are connected to each other, then just you remember, this is connected to this is connected to this, means what you are observing, all the positive plates are connected ultimately at the same point, and all the negative plates, these are connected at the same another point, that is through this terminal. So this is what? This will be similar to what? Parallel combination. But in parallel combination, I have explained you with very simple diagram. This is positive plate, all these positive plate are connected at same point, negative plate are connected at same point. So similar cases there, but this is some slightly analytical one. So you have to just think analytically, logically you have to think that all the positive plates are connected at same point and negative plates are connected at same point. So this type of combination is called parallel. So the equivalent capacitance will be, how many total capacitors are there? N minus 1. So What is the equivalent capacitance? Yes, if the capacitance of each plate is, if the plate area is A, क्या density sigma? Now tell me. The total number of capacitance formed is, total number of capacitance formed is n minus 1. If have capacitance C, then it will be C equivalent is equals to n minus 1 into C, because in parallel combination C equivalent is equal to C1 plus C2 plus C3 plus C4. So you will just take this one, n minus 1 capacitor into C simply. Now you see here from tomorrow we will start our next topic, electric current. Just remember, from tomorrow we will start our next chapter, electric current. Now see here, you see, beta, this is positive plate and this is negative plate. What is the plate area? Plate area is A. If a dielectric is filled completely in between these two plates, I mean dielectric constant K, and charge density sigma. What is the capacitance? What is the capacitance of this parallel plate capacitor? You know this formula. C is equals to K into epsilon naught A by D. Epsilon naught A by D is the capacitance of air filled capacitor. If air filled dielectric, then capacitance increases by K times. K epsilon naught A by D. Now we filled two dielectric. What is the separation between the plates is D. We filled two dielectric like this, K1 and K2, equally between the two plates. Yes, tell me, what is the equivalent capacitance in this case? See here, beta, you can assume this may be second capacitor, and this part may be second, and this one is the first one. See here, for this plate, for this part, half of the area of the plate is in contact with the dielectric K1. So, area of the plate, here you make two capacitors, this as a C1 and this as the C2. And both these two capacitors, their positive plates are connected at the same point and negative plates are connected at the same point. So, we will write C equivalent is equal to C1 plus C2 because this is in the parallel combination. So, beta, what is the area of the first capacitor? Plate area. Plate area क्या हो गया बेटा? Yes, Subham. Kamal, tell me, what is the plate area?
A by 2.
A by 2, and separation is D. So for this one, K1 epsilon naught area is A by 2 and separation is D plus. For second capacitor, similarly, K2 epsilon naught A by 2D. Now, I'm changing the configuration. Now my third question changes like this. If I'm not inserting the dielectric like this now, if I'm changing the question and my question is this, these are the two plates, this is positive plate having area A, this is negative plate having plate area, this is negative plate. I have inserted the dielectric like this. This is the separation D, this is the separation, this is D by 2. Equally, the dielectric now inserted like this. This is K1 and this is K2. Now tell me, what is the, how many capacitors forms? Yes, beta, tell me, how many capacitors are there? Now again C1 and C2. Now tell me how they are connected. But in dielectric, I have already explained, dielectric are insulator. Dielectrics are insulator in which induced charge is produced. But the magnitude of induced charge is lesser in magnitude. Induced means if this end will be positive, here negative charge will be induced, and here positive charge will be induced. I have already explained this in the beginning of just electrostatic. Plus this end will be minus, and this will be plus. Plus minus plus minus. See here, beta. Assume this positive, positive, negative. Positive, negative. See here. This is one capacitor. This is second capacitor. How they are connected? Plus, minus, plus, minus, plus, minus. How they are connected? How they are connected? This is first capacitor C1. This is second capacitor C2. How they are connected? They are connected in series. Now they are connected in series. Plus minus. बेटा see here. एक डायलेक्ट्रिक यहाँ है बेटा. ये प्लस है प्लेट और ये एंड बन गया नेगेटिव. इसके बीच में डायलेक्ट्रिक फील्ड बनाया. डायलेक्ट्रिक कैसे फील्ड बनाया? ऑपोजिट डायरेक्शन में. एंड दैट्स व्हाई इट इज प्लस टू माइनस. सोर्स फील्ड प्लस टू माइनस. Now the dielectric is decreasing the field and that's why potential and hence the capacitance increases because C is equals to Q upon V because the potential is minimized by the dielectric. तो बेटा एक ये बन गया plate area A and separation क्या होगा D by 2. Now in this case what is the value of C1? K1 epsilon naught area A distance D upon 2. बेटा you are getting or not? बेटा यहाँ डिस्टेंस क्या हो जाएगा d by 2. सिमिलरली यहाँ क्या हो जाएगा बेटा C2 क्या होगा K2 एप्सिलॉन नॉट एरिया तो प्लेट एरिया एरिया है बेटा और डिस्टेंस विल बी d अपॉन 2 कहाँ चलाएगा बेटा यहाँ चलाएगा. Now how they are connected in series? So what is the formula for series combination? C equivalent is equal to 1 by C1 plus 1 by C2. Take LCM C1 C2 plus C1. C equivalent 1 by C equivalent. So revert this one. C equivalent is equal to product of 2 divided by sum of the 2. C1 C2 or C2 C1 plus. This is the formula. Now in place of C1 write down this one. In place of C2 write down this one. Then C1 plus C2 we can find out the equivalent capacitance formula. Now see here. See question number third. Question number third is like this. This is positive plate of the capacitor. बेटा ये positive plate है और ये negative plate है. Similar condition is here. Positive plate. This is negative plate. Plate area A. Now see here बेटा. Tell me all of you. This is K1, this is K2, K3. Yes, beta. How many total? There are 3 dielectric. What is the separation? This is D. Total separation is D between the two plates. And this separation is D by 2. It means that this separation is also D by 2. Now tell me, how many total capacitors form? Yes, beta. Subham, how many total capacitors form? बेटा जल्दी बताओ how many total capacitors form Vidit? बेटा this one 3. Is first C1, this is second
3.
Yes, very good beta. C3, this is C3. Now beta see here C1 and C2 how they are connected? Plus minus they are connected in series. So for C1 K1 epsilon naught area becomes what beta? A by 2. Beta distance become tell me beta distance क्या हो गया? D by 2. What is the separation for this plate capacitor C1? D by 2. Beta 2 cancel out. K1 epsilon naught A by B. Beta similarly for 2 K2 epsilon naught A by B. C3. Beta now what is the equivalent capacitance of these two? C1 2. Both are connected in parallel. So product of these two K1 into K2 epsilon naught A by D का whole square. Product of this divided by sum of these two. Epsilon naught A by 2 into K1 plus K2. Sum of these two. Take this one common and K1 plus K2. This cut and C12 becomes what is C12? Equivalent capacitance of 1 and 2. That is C12 becomes epsilon naught square cancel out. Epsilon naught A by D into K1 into K2 divided by K1 plus K2. Now see here, beta. All of you say, beta, see here. Now we have derived the equivalent capacitance of C1 and C2. Now C3. Yes, beta, tell me, what is the capacitance of C3? K3 epsilon naught. Area becomes A by 2 and distance is D. Now, how these two are connected, beta? Tell me. Beta, tell me how these two are connected. C12 and this. Their positive plate at same point and negative plates at same point. We have first find out the equivalent capacitance of first and second capacitor, that is C12, and we treat them as a single capacitor C12. This is C3. How they are connected? Their positive plates are connected at same point and negative plates. So we can see that C12 and C3 are in parallel combination. So what is the C equivalent, beta? What we have to do? C12 plus C3. Simply add करना है बेटा. Now what is the C12? Epsilon naught A by D into K1 into K2 divided by K1 plus K2. बेटा C3 क्या है? ये है. इसका भी कॉमन लो. Epsilon naught A by D कॉमन ले लिया. बेटा क्या करेंगे? यहाँ लिखिए बेटा प्लस साइन और ये आ जाएगा K3 by 2. K3 upon 2. This is the equivalent capacitance. This is the equivalent capacitance of this given combination. Yes. Now you see here is a problem. And this problem has been asked in your JEE examination, JEE advance. Yes. Now, can anybody, what is the, it is given that plate area is A. Plate area is A. And it is given that the width of the plate is B and its length is L, B. Now, two dielectrics are placed diagonally. This one is the first one dielectric. What is the separation D? And this is the second dielectric. Now tell me, this is K1, this is K2. Now can you say how they are connected in parallel or series? Nobody can now say. बेटा कोई नहीं बोल सकता कि कहाँ पैरेलल है कहाँ सीरीज है. तो इस तरह के क्वेश्चन को कैसे करेंगे? By the use of calculus method. Now you see it. But first you move a distance y and you draw a very small move a very small differential length ahead dy. This distance is dy. Now you see here, beta, what is the plate area in this region? Now we can assume there are two capacitors. In this region there are two differential small capacitors which are connected in, how they are connected? In series. We can write this as DC1 differential capacitor C1 and differential capacitor C2. But this thickness be X, this length be X, and this length be D minus X. Now, but anybody can say, oh, what is the value of DC1? K1 epsilon naught. What is the area? Area of this region is length into breadth. What is breadth? B. What is length? dy. dy into b. Length into breadth. Upon epsilon naught k, epsilon naught a by d. What is the separation of this region is x. Now similarly DC2. Let us see here. For region DC1, we have find out this one. Now for DC2, K2 epsilon naught a plate area dy into b. And what is the separation? Epsilon naught a by d. Here the separation between the plates for this region is d minus x. Better now, what you have to do?
you have to find out the value of C1 and C2 individually, or you can do like this. 1 by C, how they are connected in series, 1 by DC equivalent is equals to 1 by C1 plus 1 by C2. Write the value of DC1 and DC2. Now here, but since here are two variables, dy and x. So